Find the stationing of point D. In this problem, a crest vertical curve extends from point A to point C and has a length of 600 feet. Lines tangent to the curve at point A and point C have the respective slope values g1 and g2 and intersect at point B, where the stationing and elevation is provided. Point D is located at the highest elevation on curve AC. For this problem, we'll define the horizontal length x as the horizontal distance from point A in the direction towards point C. Therefore, at point A, x equals 0, and at point C, x equals the length of the curve AC, which is 600 feet. And the horizontal length between point A and point D equals xd. Therefore, we can equate the stationing of point D to the stationing of point A plus the length xd. We can compute the stationing at point A by knowing the stationing at point B and the length of curve AC. The stationing at point B equals 8 stations, and the length of curve AC is given as 600 feet, or 6 stations. This makes station A equal to 5 stations. Next, we'll solve for variable xd. Since the problem states point D is the high point on curve AC, we know xd equals negative g1 divided by r, where g1 equals the initial slope of the curve as a percentage. This slope is sometimes called the approach slope. Variable r represents the rate change of slope along the length of the curve in units of percent per station. The problem statement provides the initial slope, which is 1.25%. The rate change of slope equals the final slope g2 minus the initial slope g1, all divided by the length of the curve, L. We've been given variables g2 and g1, and for our curve AC, the length of this curve equals 600 feet, or 6 stations. This makes the rate change of slope of the curve equal to negative 0.667% per station. Now we can solve for the value of xd, which equals negative 1.25% divided by negative 0.667% per station, which equals 1 plus 87.4, which is in the units of station. And finally, we can solve for the station at point D by adding 5 plus 00 stations to 1 plus 87.4 stations, and the stationing at point D equals 6 plus 87.4 stations. When reviewing the possible solutions, the answer is C.